In this video, we're going to continue RP3 with converting measurements. Now, the first thing we need to understand here is we're going to write down what we know. So in this problem, we're converting inches to feet. So in inches to feet, if you don't know, you're going to be given a conversion chart, but this is probably one of those that you should know, even if you have ever been to a restaurant like Subway. Subway has a foot long. Half of that is a 6-inch. So 2 6 inches together makes 1 foot long. So a foot long is 12 inches. So we're going to put 12 inches and 1 foot on bottom. Now, the trick to these is you can invert this and put feet on top, inches on bottom, and that's completely fine. As long as the right on the right side of the equal sign matches up and you have inches to inches and feet to feet, it does not matter if you put inches on top and feet on bottom or vice versa. It is the exact same thought process. So we have what we know first. We know that 12 inches is 1 foot, and we want to know about 48 inches. So we're going to put 48 on top and a variable on bottom. So in this type of problem, you can do it 2 ways. You can do 12 times 4 and 1 times 4, or you could crisscross multiply and say 12 times x is 12x. And then 1 times 48 is 48. Now remember, this is 12 times x. So to isolate that x, we're going to do inverse operations. So instead of multiplying by 12, we're going to divide both sides of our equal sign by 12. 12 divided by 12 is 1, which leaves us our x. And then 48 divided by 12 is 4. So that's how we get that x equals 4. Now the next one, we have gallons to quarts. So what do we know about gallons and quarts? There are 4 quarts, to 1 gallon. Again, you can put gallons on top and quarts on bottom. That is completely fine as long as the right side rate matches the left side rate. So we're going to put quarts on top here, gallons on bottom. So we want to know about 2 gallons. So I'll put 2 beside gallon, and I'll put an x beside quart. So again, you can say 1 times 2 is 2, 4 times 2 is 8. You could crisscross and say 1 times x is x or 1x, and then 4 times 2 is 8. So that's the same thing. So you're looking at 2 gallons is 8 quarts. All right, here we have inches and yards. If you have inches and yards and that confuses you, you could always think about what you know about inches and feet. There are 12 inches in 1 foot. There are 3 feet in 1 yard. So that's going to give us 36 inches in 1 yard. So 36 inches, I'm going to put that on top, and then 1 yard on bottom. Again, you can put the 1 yard on top and the 36 inches on bottom. That's completely fine. It still will work as long as the right side will match the left. So we're going to put inches on top, yards on bottom. I want to know about 24 inches. Now, this is a perfect example of how multiplying, going from 36 straight to 24, figuring out a method there, may not help us so much on this problem. So crisscross multiplying would probably be our best route to go here. So x times 36 is 36x. And then 1 times 24 is 24. Now, watch carefully to this. This is where we're going to divide both sides by 36 because we're using that inverse operations. 36 divided by 36 is 1. But now notice, we can put this in our calculator and get 24 divided by 36 and get our answer. It's going to be a decimal. Or we can just leave it a fraction and simplify. So 24 over 36. We can simplify this by their GCF of 12 and get 24 divided by 12 is 2, and then 36 divided by 12 is 3. So x is going to be 2/3. So 24 inches is 2/3 yards. So not a whole yard, but it's pretty much 2 feet, because if you think about it, 3/3 would be 1 whole yard, and then that would be 2 feet inside that yard. So that's one way to look at that. Another thing I want to talk about is metric units. Now, we have a little catchphrase that goes with metric units. It says, King Hector died unexpectedly drinking chocolate milk. This U right here is what we call a unit. It is grams, liters, and meters. We think about this as like a root word, okay? Then you have the kilometers, kilo, hecto, and deca. These are all prefixes. You have deci, centi, and milli. Again, all prefixes that can be added to that unit itself, okay? Now, We got 3,000 meters. We're going to start right here at the U because that's the meters. That's the root word. And we're trying to get to kilometers. So we're going to go to the left 3 spaces. But listen carefully to what I'm fixing to say. It's very important for you to understand. We're going to divide by 10 to get here. Divide by another 10, which means so far we've divided by 100. Divide by another 10, which means we are really dividing by 1,000. We're getting smaller by 3 place values, which is dividing by 1,000. So instead of 3,000 meters, we're going to move our decimal 3 places in, which gives us 3 kilometers. On this one, we have 1,500 grams, and we need to get to kilograms. So we're going to start at the unit because that's our root word grams. And we're going to go to kilograms. So we're going to move to the left 3 spaces. Once, twice, 3 times, which gives us once, twice, 3 times. I jumped ahead there. 1.5 kilograms. Now, here's one where we're going to go the opposite direction. So we're starting again at 5 meters, which would be our U, our units, because we have grams, liters, and meters. So we're going to start here and we're going to go to centimeter, which is right there. So we're going to multiply by 10, multiply by another 10, which means multiplying by 100. So you could go up here to 5. Your decimal is behind the 5 because it's a whole number. Move it 2 times to the right, which means we're multiplying by 100. So that gives us 500 centimeters.